Good morning, students. Today I will continue my previous topic, that is packing in crystalline solid. Last lecture I have already discussed the arrangement of atoms in a crystalline molecule can be understood with the help of packing. Packing explains how the atoms are arranged within a molecule of crystal. So last class we have discussed three types of packing are possible: one-dimensional packing, two-dimensional packing and three-dimensional packing. One-dimensional packing is one type only, two-dimensional packing are two types, whereas three-dimensional packing are three types. So today my topic is packing in crystalline solid. First we start one-dimensional packing. In one-dimensional packing, only one axis is possible and the arrangement of atoms within a molecule in such a way, that is, suppose all circle center are connected to each other, then a straight line become obtained and one circle touches by two circles. That's why the coordination number is equal to what? 2. Only one axis, x-axis, alone atoms are arranged. That's why this type of packing is known as one-dimensional packing. The second one, two-dimensional packing. Two-dimensional packing are two types, that is A, two-dimensional square packing. That is, atoms are arranged along x-axis and y-axis, both. That is, suppose if we consider this circle, then it touches into how many circles? 1, 2, 3, 4. The square becomes formed. That's why this type of packing is known as what? Two-dimensional square packing. In two-dimensional square packing, the coordination number is equal to 4. We can also find out packing fraction. In two-dimensional figure, packing fraction is explained with the ratio of two areas. So, suppose if we consider one circle, then 1/4 part of circle is covered by a square. How many total circles are involved? 1, 2, 3, 4. So total 4 part. That's why the number of atoms per unit cell is equal to what? 1. We know that area of one circle is pi r square. Suppose this radius is capital R and this one also said to be R, then this total distance is called what? 2r. So we know that the area of a square is equal to what? A is a square. We can write what? 2r square. Let's give the result what? Pi/4. This is number of atoms per unit cell. Here the area of one circle, and downward we can take what? Area of unit cell. If we want to determine packing efficiency, then let's give the value of what? Pi/4 into 100. This is packing efficiency, and that was packing fraction. Packing is two-dimensional hexagonal packing. Two-dimensional hexagonal packing. It is also said to be two-dimensional. Why? Because packing occurs only two directions, that is x and y axis. Y axis. Let us consider the pattern of packing. This is considered to be A type. This one is B. Again A. This one become B. Again A. This layer is B. So a first layer is different from second layer, and third layer is similar to first layer. Then this type of packing is called what? Two-dimensional hexagonal packing. Suppose if we consider this circle, how many circles are linked? 1, 2, 3, 4, 5, 6. We obtained what? Hexagonal figure. Therefore, the coordination number is equal to what? 6. If we find out the packing frequency, then we can write packing fraction, the number of atoms per unit cell. If we consider hexagon, then 1/3 part of the circle covered. Therefore, we can write what? 1/3 into 6, 2 part. And this is one circle. 2 plus 1, 3. So number of atoms per unit cell 3. And the area of circle pi r square. Here we find out the area of what? Hexagon. Consider this equilateral triangle. We know that the area of equilateral triangle is what? √3/4 into a square, means radius. The radius is equal to r plus r, 2r square. How many equilateral triangle are formed? 6. 1, 2, 3, 4, 5, 6. Multiply by 6. We get 0.91. Packing efficiency is equal to 91%. So always remember, in 2 dimension the packing fraction value is equal to what? 0.91. Why this type of packing is called 2-dimensional? Because packing occur in only 2 directions, that is x and y axis. So next packing is 3-dimensional packing. 3-dimensional packing. We know very well 3-dimensional packing are 3 types. The first one, 3D square packing, that is A types. This packing is similar to this type of packing is similar to 2D square packing, but packing according to 3 directions, x, y, and suppose this one z. So let us consider our 2-dimensional square packing. So in such a manner, when atoms are arranged through x and y axis, then this type of packing is known as what? 2D square packing. Suppose after first layer, if we want to prepare the new layer above the first layer, like this. That is second layer formed above the first layer and similar to first layer. Then this type of packing is called what? 3D square packing, that is AAAA types. Here the coordination number is equal to what? 6. This type of packing is known as simple cubic system packing. Therefore, packing fraction value become 0.52 because in simple cubic system the number of atom is always considered to be what? 1. So the next packing is B 3D hexagonal packing, that is AB types. It is similar to two-dimensional hexagonal packing. Look this diagram. Suppose the atoms are given. This is A layer, this is B layer. For understanding, we put atom far away from each other. Hexagonal packing always form tetrahedral wards. Tetrahedral word means the combination of 3 circles and 4 circles put above the lower circles. So if we consider here one circle, second one, third one, again you can say T is what? Tetrahedral voids. Only head appear. If we put fourth atom above the 3 atoms, all 3 atoms is in the lower level. Here the coordination number is equal to 12 and packing fraction approximately 0.74 and packing efficiency is equal to 74%. So one thing always remember कि in 3D hexagonal packing only one type of voids can form, that is said to be what? Tetrahedral. Consider this figure. Here the vacant space is available, and this vacant space is called what? O is called what? Octahedral voids. So we can say, placing second layer over the first layer, covering tetrahedral voids, placing third layer over second layer, covering octahedral voids. So this is A, this is B, and the next one is called what? C. Suppose if we consider this one, then you obtain what? Octahedral void. Octahedral means 6 circle touches by 1 circle. Here the coordination number is equal to 12 and packing fraction 0.74. Packing efficiency 74%. So this vacant space always form octahedral void. It is always remember the number of tetrahedral voids just double of the octahedral void. So it is very important note, if n is the number of points or particles or closed packed spheres per unit cell, then number of octahedral voids is equal to capital N, whereas number of tetrahedral voids is equal to what? 2n. So tetrahedral voids always double compared to octahedral voids, and the number of octahedral voids always equal to the number of particles per unit cell. At last, we have to understand the location of tetrahedral and octahedral voids. That is, location of tetrahedral voids. Look this cube. One, 2, 3, 4, 5. This point is considered to be 1, 2, 3, 4. This form tetrahedron. The 8 corners of unit cell, then 8 tetrahedral words become formed. Number of constituent unit at packing sites, we can write what? Corners and face center. So contribution by corner 8 into 1 by 8, contribution by face 6 into 1 by 2 is equal to what? 3 plus 1, 4. Number of tetrahedral words is equal to what? 2 into 4 means what? 8. So next, the location of octahedral words. Look this cube. For the location of octahedral void, consider such phases. This is 1, 2, 3, 4, 5 and 6. So number of constituent units at packing sites is equal to what? 8 into 1 by 8, because contribution by one corner is what in cube? 1 by 8. So 1 by 8 into 8 plus contribution by phase 1 by 2, 6 phases. So numerical value become equal to what? 1 plus 3 is equal to what? 4. So number of octahedral words, 1 at body center and 12 at ace center. That is 1 into 1 by 4 plus 12. It means 1 into 1 by 4 plus, we can write 1 plus 1 by 4 into 12 is equal to 4. So in next class, we will discuss how to calculate the radius of tetrahedral and octahedral voids, what are radius ratio, what are the advantages of radius ratio. Thank you.